In these notes, we're going to start with example 1, solving an exponential equation by finding common bases. And if you look at the box above, we have what we call the one-to-one property of exponential functions. And that basically says if b is greater than 0 and not equal to 1, b raised to the x is equal to b raised to the y if x is equal to y. So basically, if the bases are the same, the exponents must be the same. So what we're going to do in example 1 is we're going to try to get the same base so that we can just set the exponents equal to one another. If we take a look at letter A, we have 16 as a base and 8 as a base. So we are looking for a number that we can raise to a power to get 16, and that same number that we can raise to a certain power and get 8. So in this case, we can use 2. 16 is 2 to the 4th power, and 8 is 2 to the 3rd power. And with the 8, that 2 to the 3rd, remember we still have this negative 2x plus 3 up at the top. So that 3 just gets multiplied by the negative 2x plus 3 that's already up there. Now that our bases are the same, they're both going to be 2's, we can take our exponents and set those equal to each other. So now we can say that 4 is equal to, and as I write down this exponent, I'm going to distribute the 3 as I go along. So 3 times negative 2x will give me negative 6x, and then 3 times 3 will give me positive 9. And now all I have to do is solve for x. To do that, I want to start by subtracting 9 from both sides. And if I subtract 9 from both sides, I get negative 5 equal to negative 6x. And then I want to divide both sides by negative 6. And if I divide both sides by negative 6, I get x is equal to a positive 5 over 6. And that's my answer. If you want to check your answers, you can always take this and plug it back in here to make sure 8 raised to the negative 2 times 5 over 6 plus 3 is equal to 16. Then let's take a look at letter B. This time we have a base of 25 and a base of 125. So 25 and 125, one thing you might think of is maybe 25 would work. But if you check 25 just raised to the 2nd power, you get 625, which is way more than 125. So that won't work. So then we can try the next most obvious, which would be 5. And we know 5 to the 2nd power is 25. So we can change this to 5 to the 2nd, remembering we have to multiply by whatever's originally there in that exponent, which is the 3x plus 8. And 125 is 5 to the 3rd power. Now that we have these exponents, or these bases the same, we can set the exponents equal to one another. When I bring this exponent down, I'm going to distribute the 2 along with it. So 2 times 3x will give me 6x, and 2 times 8 will give me 16. And that's going to be equal to this exponent, which is just 3. Then to solve for x, I need to start by subtracting 16 from both sides. And I get 6x equal to negative 13. And then I'm going to divide both sides by 6. And I get x is equal to negative 13 over 6. And just like before, you can check your answer. Take the negative 13 over 6 and plug it in for x and see if you get 125 on that left-hand side. Now what I'd like you to do is to try this. So you can go ahead and pause this and check your answer when you're done. If you did the try this correctly, you should get x is equal to 31 over 5. If you have questions on how to get that, please let me know.